today we're going to talk about graphing piecewise functions. So this piece of paper will go in your notes, and this will be the last thing that is on your Unit 1 test. That will be next class. So I'm going to go ahead and I'm going to highlight my title. And then the first section of this notes sheet is review. It's graphing lines review. So I want you to pause this video, and I want you to try graphing these two problems without my help. Obviously, if you don't remember how to graph a line, then you want to just stay and then I will explain it. But ultimately, hopefully, you really know how to graph a line on your own, and that way we can make this lesson a lot easier. So pause the video, graph them, and then unpause, and I'll explain it, or you can just fast forward to where the answers are to check your answer. Okay? So number one, in order to graph a line, first off, I know this equation is a line because it's in y equals mx plus b form. Okay? And linear equations have, the biggest exponent they have in their equation is 1. So since you have the only exponents are 1, you know it graphs a linear function. So in order to graph a line, it has to be in y equals mx plus b form. And in y equals mx plus b form, you need to know what m equals and what b equals. So b is always your constant, which is -3. And m is your slope, which is the coefficient of x, which is 2 over 1. So when I'm graphing a line, I'm going to plot b first on the y-axis, so -3. And then I go up 2 over 1, plot a point. Up 2 over 1, plot a point. And then I just keep going all the way across my paper. And I connect my dots. If you look at number 2 is not in y equals mx plus b form because y is not isolated. So I have to get y isolated. So I'm going to add 5x to the other side. So I'm going to add 5x. So I have 2y equals 5x. And then I'm going to divide by 2. So y equals 5 over 2x. So m equals 5 over 2. And b equals 0 because there's no constant. So I'm going to plot 0, 0, and then I'm going to go up 5 over 2. And I should probably apologize that you might be able to hear Gus in the background, but that just means he wants to learn algebra as well. So then I'm going to connect my dots. And hopefully when you connect your dots, it looks a lot prettier than what I just did. All right, so let's go ahead and let's keep going. So it says, so I can scroll. What is a piecewise function? So I'm going to go ahead and I'm going to highlight what is a piecewise function. So technical glitches here, sorry about that. So a piecewise function is a function that is defined by subfunctions. That pertain to a specific interval. Okay? So a piecewise function is one function that's defined by a bunch of subfunctions. Right? This means many functions to make one big function that pertain to a specific interval. All right? So if you go ahead and you look down at some of these examples, if I look at example 1, notice I have 2 lines, but I'm given restrictions. These restrictions are the specific intervals in which they fall. Okay? So I'm going to go ahead and if I can scroll, let's see. All right, awesome. I'm going to graph 2x plus 1 all the way through. So 2x plus 1. So plot 1, and then I go up 2 over 1, up 2 over 1, up 2 over 1, all the way down. But I'm not going to connect my dots because now I need to pertain my given interval. So if I take a look at my specific interval, it has to be less than 1. So when is x less than 1? So x is 1 right here on your graph, yes? So what's less than that? Is it to the left or to the right? Well, it's to the left. So anything to the left, I'm going to connect. And anything to the right, I'm going to erase. Okay? So now I'm going to go back and look at my restriction. X is less than 1. So does that mean at 1 I have an open dot or I have a closed dot? Well, since it's less than 1, I have an open dot, and I'm putting it in the wrong spot. Open dot right there. Okay? So now I'm going to go ahead and I'm going to graph negative x minus 1. So negative 1, down 1 over 1, down 1 over 1, because it's negative. And I graph it this way because it helps my brain see it so I can visualize it a little better. So now I have x is greater than or equal to 1. So x is 1 here. So since it's greater than 1, it's going to go to the right. And then I erase all my green dots to the left. So let's and then you could reconnect that yellow line if you needed to. Oop, and it just made it green. That's fine. All right, and if I look at my restriction, x is greater than or equal to 1. Since it's greater than or equal to, it's going to be a closed dot. Okay. So if I go ahead and I do number 2, same thing. I pick a color. 2x plus 5. I'm going to graph that first. So 2x plus 5 is here. And then I go up 2 over 1. And I go all the way across my grid. And once you get good at this, you can be able to determine the restrictions on your own. But until then, that's what we do. And then it says x is greater than or equal to negative 3. So negative 3 is here, right? And it's going to be a closed dot because it's greater than or equal to. And since it's greater than or equal to, is that going to the right or to the left? It's going to the right. And then I can erase everything else. And if I do 1/3 x plus 4, so 4 is here, up 1 over 3, down 1 over 3, and then it has to be less than negative 3. So at negative 3, it's here. It's going to be an open dot because it's less than. And then it goes to the left because it's less than, not greater than. Okay. So I scroll. If you want to go ahead and pause this video and try number 3 on your own, then unpause it and then we can go over it together. So if I go ahead and I explain it, negative 3 x over 2 plus 1. So I'm going to go up 1, and then I'm going to go down 3, right 2, down 3, right 2. And then it's it's less than 4. So at 4, it's going to be an open dot. And then connects. Sorry, drawing on the air makes my life a little wobbly. If I just look at negative 2, well, just y equals negative 2. So y equals negative 2 here, right? But it says it has to be greater than or equal to 4. So 4 is here, and it's going to be a closed dot, and it's greater than, which means I can erase all of this side. So one thing I want to mention is notice how your intervals, it always looks like a jump with the discontinuity type of discontinuous function. Chances are it's almost going to always look like that. Sometimes they might overlap, but not always. But most of the time they will look like a jump type of discontinuity. Okay. So go ahead and pause the video and do number 4, and then unpause the video and I will go over it. So if I plot the first one, it's going negative x, and it's going to be less than 0, right? So I'm previewing ahead. So less than 0, it's going to be a closed dot at 0, and then less than, it's going to be here. So I can just go ahead and erase that, right? And then negative 2x over 3 minus 1. So that's here. And at 0, it's an open dot, right? And then, here, let me do it a little better. At 0 is an open dot. And then I'm going to go, it's between 0 and 5, so it's on the positive side. So down 1, 2, over 1, 2, 3. Down 1, 2, over 1, 2, 3. Okay, and it's between 0 and 5, but notice, is 5 perfectly on one of your points? No, which means this is a typo. Oops, I'm erasing too much. So if you change that 5 to a 6, that's a typo. So now that it's at a 6, now I can connect that. Okay, and now I have y equals 2, but it has to be greater than 5. But again, to make this a perfect piecewise function, I'm going to fix it to a 6. So 2, I have 6, and it's an open dot going that way. And why I have to do it this way, and why I knew these were typos, is because first off, I knew that was a typo because when x was at 5, it didn't fall perfectly there, so I knew something was wrong. I needed to fix this one down here in order to keep it a function. So closed fills open, so it's still a actual function. So this whole thing is technically a function, which is what a piecewise function is. If you go back to our definition, a piecewise function is a function of subfunctions. So line, those are all functions. Okay? So then you flip your paper. So now I'm going to evaluate piecewise functions. So when g is -3, am I plugging it into this top equation or am I plugging it into this bottom equation? Well, I want to plug it into the top equation because it fits this restriction. -3 is less than -2. So I got to plug it into the top equation. So I would do -3 plus 5, that equals 2. So g of -3 equals 2. If I had to plug in g of 4, am I going to plug it into the top equation or the bottom equation? Where I see which one it fits the restriction. 4 is not less than -2. 4 is greater than -2, so I plug it into the bottom one. -2 times 4 minus 1, that makes -9. And if I do the last one, g equals -2. Is that the top one or is that the bottom one? Well, it's the bottom one because this one's greater than or equal to. So I would do -2 times -2 minus 1, which is 4 minus 1, which is 3. So go ahead and pause the video and try number 2 on your own, and then unpause it, and I'll have the answers on the board for you. So if I look at these problems, if I'm -4, I plug into the bottom one. So I have -4/3 plus 4, right? So I got to change this into common denominators. So that's going to be, oops, that's a 3. I shouldn't have done that, sorry. 3, so I'm going to change that to 12. So that's going to be 8/3. And if I plug in 8, I'm plugging 8 into the top. 4 times 8 is 32. Minus 2 is 30. And if I plug in 2, I'm going to plug it into the top equation because that's where it's equal to. So 4 times 2 is 8, and 8 minus 2 is 6. Okay. So let's go ahead and keep going. So go ahead and try 3 and 4 on your own, and then pause the video, and I'll put the answers on the board for you. So hopefully these are your answers, and I didn't make a mistake somewhere. Put the answer keys also on the classroom in case I did, but I don't think I did. But you can tell me if I'm right or wrong. So let's go ahead and now let's work backwards. Working backwards, write equations for piecewise functions are the graphs shown below. So I see this equation, and I see this line. So I'm going to first write the pink line. So I'll even write it in pink. So b is 0, right? And my slope is 1, 2 over 1, 1, 2 over 1. So n is 2 and b is 0. So I have y equals 2x, right? And then my green one, set at 0, down 1 over 1, down 1 over 1, down 1 over 1. So that's y equals, m is negative 1x plus 0. So now if I want to write the piecewise function, I would do f of x or g of x or h of x, it doesn't matter, and then I do my squiggly brace. And then I would write my two equations. Now I got to do my restrictions. So if I go back and I look at this pink one, x is greater than or less than. It's going to be greater than because it's going to the right. And is it greater than what? It's greater than 0. So x is greater than 0. And the green one restriction is going to the left, so it's less than. So x is less than 0. Now, if both of those were open dots, which is what my answer right here says, this would technically not be a function. If both of them were closed dots, it would also technically not be a function. So usually you have to make one less than or equal to, or one with the equal to and one without. So I'm going to do the green one because that's the pen that I had. You could also do the pink one. On a test, it'd be very straightforward which one had a closed dot, which one had an open dot. A lot like example 2. So I'm going to try example 2 on your own, and if it doesn't look like it does the perfect corners on your green, we're just going to assume that it does. Okay? So we're going to assume this point goes here and this point goes here. All right? So pause this video, you try that one on your own, and then we'll go over it together. Okay, sorry, getting my bearings straight. So my slope on this one is up 1 over 1, up 1 over 1. So I'm going to go down 1 over 1. That's my y-intercept. So b is 1 and m is 1. So y equals x plus 1. So now if I come and I do this one, I'm going to assume it's up here, over 1, down 1, over 1, down 1, over 1, down 1. We're going to say it's over 1, down 1. It's not perfect. So m equals negative 1 and b equals 2. So now I have y equals negative x plus 2. And if I look at this last one, I want to assume it's here and here. 1, 2, 3, 1, 2. So that would be m is 3 over 2. And b looks like it's 1, 2, 3.5. I'm going to say it's 3.5. So if I write my answers, f of x equals x plus 1. That restriction is at 1, so x has to be greater than 1. It's greater than because it's an open dot. If I go to the blue line, I have negative x plus 2. X is less than negative 1 because it's on negative 1. And last one, which is my yellow line, I have 3 over 2x plus 3.5. And then x is between two numbers. It's between negative 1 and positive 1. So I do negative 1 less than x less than positive 1. Why it didn't have equal to signs? Because it all has open dots.